Okay, now that we've covered some of the basics of inputs and outputs and programming using the Arduino IDE, we're going to start to cover different sensors and actuators that come with the kit that you guys got with your Arduino. The first thing we're going to cover is the photoresistor. This photoresistor element right here. The way this element works is when it's in a very dark environment, it has a very high resistance. Then as it gets brighter and brighter, the resistance in the element goes down. So at maximum brightness or in very bright light, it has a very low resistance, and when it's very dark, it has a very high resistance. So since the resistance here varies, when we apply a voltage across it with another resistor in series, it acts like the potentiometer, where the resistance on this end, if it's very high, the voltage here is going to be very low because the voltage resistance of the photoresistor relative to my passive resistor here is going to be much higher. Whereas when the resistance here is very low, the voltage drop is going to be mostly across the resistor and less across the photoresistor. And that allows us to transduce the brightness at the resistor, at the photoresistor, into a voltage which we can then measure. This is still considered a passive element because the transduction of the ambient light conditions into the resistance doesn't require any kind of active control. It's basically can be done in a purely analog system. There's no feedback or signal that I really need to send to this other than a power source. So it's a very common element. It's very easy to use, and so that's one of the reasons we're going to be starting with this one. This is the circuit that I have set up for this one right here. Again, we have power going to again, there's no real side to this one since it's a resistive element, so it doesn't matter if it's anode or cathode. But going to what I'm going to call the anode side of the photoresistor, the cathode side of the photoresistor is also connected to the 100 kilo ohm resistor, and then that's also connected to my terminal A1, my analog input A1, and then the other side of the resistor just goes to ground. And we're going to see how this works in the physical circuit. So let's build this up. I've got my photoresistor here. Again, it looks a lot like the element shown in the diagram there. It's basically just a little plate with kind of a squiggly line looking between it. I'm going to put this on the opposite side of my breadboard close to my LED. And I want that next to my LED so I can use the LED to kind of shine on it and make it brighter or darker by controlling that LED as well in a future activity. And then I'm going to take my 100 kilo ohm resistor. Again, you can use different resistances here, but depending on your ambient light conditions, you kind of want to get close to whatever the resistance of the photoresistor is going to be in your normal lighting conditions if you're going to be using this. It's going to give you kind of the most sensitivity. It doesn't matter too much because we can account for a lot of that in the programming side. But again, keep in mind that if you use a resistance that's very, very high or very, very low, it's not going to work as well. You're better off to be on the side of a higher resistance because then the amount of load that the circuit will use will be less. So the total current draw will be less if you have a higher resistance. So that's why I went with 100K. Here you go. So I've got those two elements in series. I want to put power on the photoresistor side. And then again, I'm connecting this to the positive line on my breadboard, which is connected to 5 volts on my Arduino, just like it was last time. Again, I haven't really modified this circuit from last time. You don't need to have all of these elements to do this, but again, rather than taking things in and putting them off, it's easier to try and leave them in so you can use them as you develop this. Then the negative side, or the ground, I'm going to attach to the negative line on my breadboard, and again that goes to ground on my Arduino. And then the junction between the photoresistor and the regular resistor is going to plug in there. And again, I'm going to connect this across to my A2, or sorry, my A1 on my Arduino. That doesn't quite reach. So let's do this. Let's see if I have a longer yellow line. Looks like they're all about the same length. So what I'll do is, I'm just going to move this closer Did I accidentally pulled out my photoresistor. Just plug that back in. Plug this into my A1. I'm just going to have this go to an unused row on the breadboard. And then I'll do another line going from that blank row to my photoresistor. And the real disadvantage of leaving all this stuff plugged in all the time is that it is going to get cluttered pretty easily here. Alright. I've got that set up now. So now I've got the circuit kind of built out in the same way as I had in that diagram here. You can see this is the photoresistor here. This is the regular resistor. Sorry, I don't have a good zoom on this webcam, so I can bring it closer, but then it just gets fuzzier. Anyways, in my code here, this is the code that we started with last time. I'm just going to save this as a new file. So I'm going to name this LED with photoresist. And I don't really want to do a whole lot of stuff with the button on this. One thing you can do if you have a code that you want to keep, but you don't want to use any of it, so you just want to have it there for future reference, if you right click on it, you can comment, uncomment a whole range, and now it's going to ignore that entire section of code. So I can still copy and paste from those if I want to use that, but it's not really going to do anything. I did add a new element onto this, the analog input A2, or sorry, A1. So I'm going to put this on here. So I'm going to do int photo sensor. Let's say that A1. And this is the pin for the photoresistor. Really, it's a photo sensitive sensor circuit because I have the photoresistor and the regular resistor and the power line. But keep your names simple, right? All right. Now on here, what I'm going to do is I'm going to turn the LED on just so I have a light source. So to do that, I'm going to use a digital write. Of the LED pin. I'm going to set that to high. That'll turn my LED on. Again, I was looking for that inside this code here, but I had changed it to the analog right. And then I need to get the value of the photoresistor using the analog read command. So just like we did with our potentiometer, I can get the photo, let's just call it brightness, of my photosensor pin. Again, I don't need to specify the analog inputs as inputs because they're default to inputs, because that's what they're used for. And then for now, all I'm going to do is I'm going to print out the brightness on that. So I'm going to use the serial print command, serial print line. I'm going to print out the brightness. And to keep this from going too fast, I'm going to delay this by 100 milliseconds. So that way I only get an update, one update every tenth of a second, or about that. Again, it's going to take a little bit of time to do the other commands, but we'll have that. All right, let's plug this in and see if it works. Plug it in the computer side as well. My cat's a little tangled in that cord. All right. Just compiling. taking a while for this to compile, so I'm just checking to make sure things are connected properly. There it goes, uploading. And there we go, it's on. So let's look at our serial monitor and take a look and see what values we're getting off of the brightness. So this one, the way we set this up, the brighter it is, the lower the resistance in the photoresistor is, right? So the lower the resistance in the photoresistor, then the higher the value, right? So when I put this card in front of it, see it goes down, take it out, goes back up, down, goes back up. See that? So what this is really called, this is called a photoresistor gate. And this is an important circuit because we use this a lot for a lot of different other things, kind of as an extrapolation of this. I can use this as basically a detection sensor to know when a rotation has been completed. I can put a bunch of little windows on a disk and then count as those windows go by. And we'll build on this a little bit to show we'll do the number of counts to see how many times I pass the card in front of the resistor. But we need to know what the value of this is in both the opened and the closed or impeded states are for us to be able to do that. So it looks like 947 is pretty consistent when the light is shining on it, and then 800 and something is when it's not on it. So it looks like 900 is about the threshold on this. So I'm going to go ahead and try and code that into thing to try and detect when I pass that 900. So what I'm going to do is I'm going to say that we have the current brightness. So this one here says the brightness, right? And this right now, this is a local variable. So let's replace this and make two global variables. We'll have the brightness, and we'll have the previous brightness. I'm going to set them both to 900 to start with. I'm going to put a note here, photoresistor brightness. Now that I've got that, the previous brightness, what I want to do is before I update the brightness, I'm going to set the previous brightness. So previous, let's copy and paste. Previous brightness is equal to brightness, and then brightness is equal to the analog read. So in this state, when I get to here, this brightness value is whatever it is on the current loop. This one is whatever it was on the previous loop, right? So I'm updating this one, so it's always going to lag, basically one cycle behind the previous one, right? And let's slow this down a bit more, and let's actually show you guys what that looks like. So let's add some more commands onto this serial to make it look a little bit easier to read. So I'm going to print, and what I'm going to print out is I'm going to print the word previous brightness. I think I need to use single quotes here. Let me try a full quote. There you go, full quote, change colors, that's good. So I'm going to print that out. And then I'm actually going to print out the variable. So this quote here makes it so it's actually going to print that text. And since I'm using print instead of print line, it's not going to go to the next line yet. So what I'm going to do is I'm going to print the text previous brightness equals to the previous brightness, a colon, really a semicolon, some space, brightness equals to the actual brightness, and then on this one I'm going to go to the next line. And I'm going to do this once every second so it doesn't update too quickly. Let's take a look and see what that looks like. And I'm mostly doing the slower update so we have time to read it before it goes to the next one. So there's the initial one here that said previous brightness equal to 900 because that was the default state. So 740, 740, 950, 950. And so you can see that the values lag. So first the brightness changes, and then the previous brightness changes. So you guys can see that. Again, so the 970, 970, 970, 970, brightness goes down, and then previous brightness goes down. And if we wanted to, we could lag multiple cycles behind by doing something similar, but for our purposes here, this will work. So now if we wanted to count the number of times that the card had gone in between the LED and the photoresistor, what we can do is we can look for instances where the previous brightness is below that 900 threshold, right? But really the previous one is above the 900 threshold and the other one is below the 900 threshold. And then we can add that to a count. So what we can say is we can say if previous brightness, and I'm going to copy and paste it so I don't spell this wrong, is, we want to count when the card goes in front of the LED. So that it's going to go from high to low. So when the previous brightness was greater than 900, and our current brightness is less than 900, let's say, curly brackets here, count, I'm going to increment the variable count. I don't want to initialize this here because I don't want to reset it, so I'm actually going to make this a global variable as well. Int count, and we'll initialize it at 0, so it starts off at 0. But every time this statement evaluates to true, I'm going to increment the count plus 1. Let's also go ahead and print out the count. Make it a little bit nicer too. We'll have a declare here for the count. So we're never going to see a count 0, or so you shouldn't see a count 0 because we're going to print it after we increment it. All right. 1, 2, 3, So it works. And again, we're doing this very, very quickly, slowly, because we're doing all of these prints. But once we know that it works, we can actually comment out these prints that we're using for kind of our debugging. Actually, let's leave these ones here just so we can see that we're actually counting up and decrease the time that we spend on each cycle so we don't miss counts on accident. Wrong button. Upload. We should be able to count pretty efficiently. And even if I do this very quickly, so it works pretty good. So we can combine this with a lot of other things to basically make counts of different passes. Hope you guys enjoyed that circuit. Play with it, and then once you're comfortable with it, move on to the next one.